Hi there. When we talk to customers about security, they often ask us, what does good look like? And the reality is, security is not about perfection. It's about systematic and continuous improvement. We've learned a lot from working with customers in our internal AWS service teams over the years. And Peter and I want to show you today what we would go back in time and tell ourselves.
That's right, and this talk is going to be a primer. So if you're already operating a cloud security organization or program, this will hopefully be a good refresher. And if you're looking to get started on the cloud, this is an overview of some of what we consider to be the fundamental core competencies that you must not just have, but work continuously to improve and refine over time. My name is Peter O'Donnell. I'm a principal SA focused on security, and I've been with AWS for more than a decade, working with some of our largest and most challenging customers. What we're going to talk about today is some of the lessons that we've learned.
And my name is Leah Vader. I'm a security engineer in AWS security, but I started my career in AWS over 10 years ago as a solutions architect, helping customers like you. And recently, I've been in our AppSec organization, helping our internal service teams build and launch securely. So these are the 7 areas we want to prioritize for you. We only have an hour, and there's so much we want to tell you. But think of this as the basics of what you should put your efforts into. We start with what I think is the most important part of our cloud security journey, which is building a culture of security. And then we get into all of the technical competencies.
And this idea of continuous improvement is really fundamental, and it needs to be part of your culture. But the more important aspect of this culture is the culture of security itself. It provides a foundation for everything that you and your colleagues and your leadership all the way across the entire organization have to be part of. And it demands rigor, rigorous, obsessive ownership that everyone in the org from all parts of the business are committed to making security the top priority. You've heard us speak about this idea this same way, that at AWS, security is job zero, our top priority. And what we know from working with our customers, and some of our highest performing customers, is that they take this same responsibility in the exact same way. That security is everyone's responsibility, it is everyone's job, and it has to be something that you obsess over and continuously refine. The role of the security organization becomes setting standards and expectations and making it easier to do the right thing and harder to do the wrong thing. But security ownership has to be with the people that are actually creating the software and the products that you are operating on the cloud. That security is not an afterthought. It is not a meeting you have at the end of a development cycle. It is a series of meetings you have at the very beginning of the ideation of the project. And as we talk about these competencies today, they need dedicated teams. They need funding. They need obsession and rigor at all levels. So let's talk about what this means to have a culture of security. We know that it's a common denominator for success. Again, not only here at Amazon Web Services, but for so many of our customers who build and operate their critical workloads on the cloud. Because culture is a series of beliefs and values, it's easy to understand it as a set of normative behavior. It's a body of things about which you've already agreed to and that you will not continue to negotiate. That the purpose of culture, I submit to you, is to eliminate continuous renegotiation about whether or not it is important. And if you approach the stairs in the west, you go up the right, and when you visit the Tokyo subway, you go up the left. And it would be insane in that moment to have a conversation about it. Culture of security demands the same. That when you're building a product, you're thinking about a launch date, when you're thinking about design decisions, that you are no longer questioning whether or not security is a top priority for it. And as you develop this in your heart, we want you to recruit your own colleagues up and down the organizational line, including your executives. That all of this is a necessary evolution for your organization to get high quality, reliable, and repeatable security outcomes. That the rigor you place into the things you are building must also be the rigor that you place into security. So we see 4 key components of the culture of security in high-performing organizations. Executive support. At AWS, our CEO spends an hour every week focused on the top security questions or topics that the team brings to him. This is fundamental to have executive support, but to be clear, it is not only exec support, it is in the bones of the entire organization. From every junior engineer to every manager, every director, every vice president, that security is everyone's responsibility. And that means distributed ownership. That application teams, compliance teams, audit teams, and most importantly, product development teams have this ownership. And in order for that ownership to work, especially for a junior engineer to be able to raise their hand and say, hey, I'm not so sure about this, you have to have a culture of psychological safety. It has to be reasonable and expected and safe to ask hard questions, to object to things that you know are not secure, to object to timelines that compromise on security. And of course, continuous education and refinement. People have to know what good looks like. Talks like this can help, but within your own organization, set standards and allow for your customers and your internal partners, your internal customers, to know what it is they need to do in order to reach high security outcomes. So how do we scale this ownership? Well, at AWS, we have this program called Security Guardians. And we've got a lot of great talks, both this week and in the past, focused on what Guardians really means. And this is another mechanism to scale out ownership. By deputizing and giving a special education and training to certain people across the organization, you could shift left not only better security outcomes, but you could shift left the idea of inculcating security culture in the minds and hearts of your entire organization. I mentioned earlier to set standards and expectations, and this is fundamental. It must be very clear what secure is acceptable and what is not acceptable for security. Correction of error. Correction of error is a unique thing at Amazon, and we want you to adopt the exact same mindset. That root cause analysis is not enough. You must endeavor to make sure that the same problem does not recur. And finally, you have to be able to measure these things. Get together, agree on KPIs, agree on metrics, and then review them regularly. If you're not measuring it, you're probably not managing it. And if you think you're getting better, you should be able to prove it to yourself. And if you think you're getting better and the metrics say otherwise, then you've got a lot to think about. So we know that good security programs accelerate the business. That you're not in the business of saying no, you're in the business of saying yes. The purpose of the brakes on the car is so that it can go fast, not to slow it down. The purpose of the guardrails are so that the car can accelerate through the journey that you're on. Security and engineering and audit and compliance all, in fact, want the same things. That the same outcomes that a great high-performing SRE would want are the same outcomes that a compliance or audit officer wants. And that you must see each other as partners and not as adversaries.
All right, so after security culture, what's the next thing? I would focus on account management. So when I first became a solutions architect 10 or so years ago, a common struggle I saw was customers trying to work around a single account strategy. And I want to talk about some of the lessons we've learned. First, multiple accounts. Organizations that build this foundation early move faster with better security controls and better guardrails than those who try to retrofit boundaries later. And if you scale too quickly, it can take a long time to unwind these decisions and create separation. Next, you need tooling. As your account structure grows, and it will grow, you must have the right tooling to manage your accounts. And lastly, security controls. You want standardized controls across all of your accounts. You need to automate this so it's predictable and reduces the operational burden on your teams. So I'd start with account structure because it's the foundation everything is built upon. And let me share what's worked for our customers. So even if you're starting your AWS journey today, I still suggest you begin with a separation like this. First, you have your management account at that top layer. It's where your organizational structure is established. And then you're going to have dedicated security accounts. And this is going to have your centralized logging, monitoring, and security tooling. And you're going to have backup accounts for administration and operations. And each team or workload is going to get their own set of accounts. And you're going to separate production from development and testing, because this not only helps helps with the blast radius, it's also about implementing appropriate controls for each environment. Now let's talk about AWS organizations. This makes that account structure I just showed you practical to manage at scale. AWS organizations gives you account management through defined organizational units, or OUs. This allows you to group your accounts by function or by environment, creating these natural boundaries. And this is important because you can apply policies to your organizational units. We have authorization policies and we have management policies. So authorization policies establish guardrails through things like what we call service control policies and resource control policies. And we'll dive a bit deeper into those later. But at a high level, they allow you to limit permissions on IAM principals and resources respectively. So an example of an SCP would be to only allow actions in regions that your organization operates in. And an RCP example, resource control policy, would be to enforce HTTPS on all of your S3 buckets. Now, so management policies, they allow you to centrally manage services and features. And what that means is it's covering things like tagging and backups, or service-specific declarative policies like enforcing VPC block public access. And we know this can be a lot to learn and manage on your own. This is why we created AWS Control Tower. Control Tower takes these best practices that we just discussed, the multi-account strategy, organizational structure, and policy implementation, and packages them into a managed service that does a lot of the heavy lifting for you. And the most successful customers I've worked with treat accounts as a strong boundary, not just an organizational one. They provision accounts through automation, they enforce consistent controls across all the accounts, and regularly assess their account structure as the business evolves. Okay, so as I mentioned, organizations can be used to deliver authorization policies, and that's part of identity and access management. So I'm going to turn it over to Peter to talk about IAM.
So one of the core primitives on AWS is identity and access management. Every API call that your software calls into the cloud is discreetly authorized and authenticated using AWS IAM. In fact, at the scale that we're operating today, we're authorizing over 1 billion API calls per second. That puts us in trillions per day. And it's fundamental to understand how these things come together. AWS IAM is a question of who is doing what actions to what resources. Pretty simple stuff. Who is doing what actions to what resources? And when you think about establishing that concept, you have to have strong authentication, and I urge you to avoid indefinite credentials. Before we had federation, before we had the STS service where you could get temporary credentials to call the cloud, we had something called IAM users. If you're starting off today, do not use IAM users. Federate your identities. If you already have IAM users, make sure that at a minimum you are rotating those credentials regularly, like secrets that you might need to call a database from an application server, or any of another variety of types of secrets, API keys to call other services. You must have high velocity rotation of those secrets. And again, avoid IAM users. If you're calling AWS from off cloud or on-prem, we have a new service as of a few years ago called IAM Roles Anywhere that allow you to use an X509 entity certificate, a digital identity, and exchange that for temporary time-bound AWS credentials that can be used to call AWS APIs. For your humans, Instead of having a username and password to log into the AWS console using an IAM user, you can federate your identity. Federation means having an identity provider in your own house. Your own company already has something like Active Directory or Entra Online. Being able to federate that identity to the cloud means exchanging that identity. We give you back temporary, time-bound credentials that are scoped exactly to the authorization policies associated with what is called a role. And again, I must emphasize, get rid of your long-term credentials. Move towards a place where everything is time-bound and that you are using federation and services like IAM Roles Anywhere to always use temporary credentials. And so we have a service that can help you do this with federation. There are other choices in the world, and you may already be using them, but if you're getting started, using AWS IAM Identity Center is a great way to do this. IAM Identity Center allows you to converge your own identities into this idea called Identity Center on the cloud. Using Identity Center, you can develop what are known as permission sets and assign those to accounts, allowing you to connect a bright line between this person or group to this set of authorizations to that AWS account. IAM Identity Center can make managing all this much, much simpler. And by connecting it to your corporate identity provider, you can use existing tooling that you have for movers, joiners, and leavers. So as people change job roles, when Dave from accounting goes over to the Treasury Department, that you lose certain permissions and gain others. And again, IAM Identity Center can help bring those together. And I must repeat again, and I'm repeating it because this is the #1 source of bad days for our customers on the cloud. Get rid of your IAM users, move towards temporary credentials. But you're also going to have non-human need for credentials to call AWS APIs. Not a user who's logged in, but a workload. A workload may be running on EC2, our virtual compute service, and AWS Lambda, our serverless, in any one of our container services, ECS or Kubernetes with EKS. Each one of these compute primitives has a way to automatically introduce temporary time-bound credentials to the workload itself. This allows you to associate an identity with where the software is running so that the software can automatically obtain temporary time-bound credentials to then call APIs, maybe write something to Dynamo, maybe invoke infrastructure on your behalf. And by using these built-in primitives, you can avoid doing dangerous and, dare I say, reckless things like putting credentials into your software directly. Do not store your credentials in config files. Do not store your credentials in repositories. Use the built-in primitives of AWS to introduce dynamic, on-demand, time-bound credentials throughout our compute fabric. And associated with each of these IAM roles that the credentials correspond with is a series of authorizations. Authorizations written in a policy language. Enforce least privilege. If you don't know what your piece of software needs to use S3, find out. If a developer brought you a container and the container was 10 gigabytes, and the developer said to you, well, I didn't really know what packages I needed, so I put them all in there, you'd say that's crazy. In the exact same way, don't permission your software with S3 asterisks. Permission your software with exactly what it needs. Now, sometimes least privilege can mean maximum effort, but we have tooling to help you figure that out. IAM Access Analyzer is a very powerful tool that got some very cool capabilities that were announced today during the keynote to help you refine and understand what permissions are being used. We make managed policies that are a good starting point, but continuously refine them down. And we give you governance and the ability to have guardrails. Leah talked about these two interesting policy types, service control policies and resource control policies. Service control policies, SCPs, are used to govern what an IAM principal can do. They bound what actions could possibly be allowed. In the exact same way, a resource control policy applies to the resources, either everything in your organization or selectively to only certain accounts based on the OU that contains that account. This idea of Access Analyzer is just one of the several tools that we have to make this simpler and easier and programmatically addressable. You must continuously baseline and refine the authorizations that you have. Access Analyzer can help you discover permissions that are assigned but are no longer in use. It can also help you discover resources that might have inappropriate access or even access from the public. By using Access Analyzer together with conscious, business-driven authorization, you can get higher quality security outcomes and reduce the blast radius of the compromise of any of these credentials. By winnowing these down, you can make deliberate choices so that you know exactly who is using what actions against what resources. So again, use this tool, Access Analyzer. It's enormously powerful, and it gets more powerful all the time. Again, Amy had a great announcement this morning in her keynote. I encourage you to check it out. Service control policies and RCPs are really effective ways of establishing governance for teams that may want to manage their own IAM, but the central team needs to put guardrails around it. Multi-factor authentication is not optional for your humans. Get away from usernames and passwords. This takes investment. It can take time. It means maybe some training for your users. But the dividends are enormous. You can unsubscribe from entire classifications of risk and threats simply by using MFA and no longer relying on just usernames and passwords. And finally, there's a special version of the way we provide credentials to EC2. I mentioned earlier that the compute fabric itself has a way of associating the identity where we introduce dynamic credentials automatically. Version 2 came out 6 years ago. It is very possible that you are still using version 1. Go home and change that.
All right, I want to talk about data protection now and the minimum that you should be considering for your organization. So when I was in SA, I saw a trend. Most organizations don't truly know what sensitive data they have and where it resides. And I've seen this pattern repeatedly. You create a solid data classification policy on paper, and then your data volumes grow exponentially, outpacing any manual efforts. Developers and business units create new data stores faster than security can keep up. And at the end, you have this widening gap between your classification policy on paper and the reality of your data landscape. So we created Amazon Macie to help. Macie is a fully managed data security and data privacy service. It uses machine learning and pattern matching to discover, monitor, and protect your sensitive data in S3. So Macie provides visibility into your S3 environment and evaluates your bucket inventory and policies and can identify configuration gaps, looking for things like public access settings or unencrypted data. So when you turn it on, you'll see something like this in the console. You can see one pane of glass, what is public, what's encrypted, how it's encrypted, and what is shared. More importantly, Macie discovers sensitive data through automated inspection jobs. And you can find a flexible scope to scan your entire environment or focus on specific buckets based on your priorities. And we talked earlier about how hard it is to manage at scale, and sensitive data normally spans accounts. So Macie solves this by integrating with AWS organizations so you can view your data security posture across your entire S3 environment from a single Macie administrator account. And you can use managed data identifiers to detect common sensitive data types or custom identifiers to let you define patterns that are specific to your business. Macie also delivers detailed findings showing what sensitive data was found and where. These findings can trigger automated workflows through EventBridge for remediation actions. This automation bridges the gap between classification policies on paper and continuous enforcement at scale, so you can maintain visibility of your data however it grows. Okay, let's move on in our data protection journey. So outside of understanding the data you have, where it is, we need to encrypt it. And Werner's quote gets right to the point. Dance like no one's watching, encrypt like everyone is. Encryption is not just a security control. It's a fundamental design principle, both internally at AWS and with our most successful customers. And when we talk about encryption, we need to address encryption at rest and encryption in transit. So let's start with encryption at rest. And specifically, we're going to talk about server-side encryption. So you have your data classification policy. Now you can align your encryption strategy. The AWS Key Management Service makes this straightforward by transparently integrating with the service you use. It supports AWS managed keys and AWS owned keys, which handle the overhead of managing these keys. However, you have the option as a customer to create your own customer managed keys that give you complete control over the key policy and the lifecycle of that key. So I want to show you an example. Here's an S3 bucket. We're going to create one. So S3 is encrypted by default. You don't have to do anything. But if you want to manage your own key and have control over the policy and the lifecycle, you can. And that's called SSE KMS, or server-side encryption KMS. And for the third option, while this may not apply to you, you may have compliance requirements for dual-layer server-side encryption, and that's available in some regions. Now, the next thing I want to show you is S3 bucket keys. And this isn't a security control per se. This is more of a cost savings control, but I think it's worth mentioning. So S3 bucket keys reduces the cost of S3 server-side encryption with KMS, because when it's configured, S3 is able to reduce the number of calls to KMS, therefore reducing your cost significantly. Okay, now let's move on to client-side encryption. So based on your data classification policy, you may want to encrypt your data prior to sending it to AWS. And the AWS Encryption SDK and the Database Encryption SDK make this approach easier without requiring cryptographic expertise. The Encryption SDK handles just general purpose encryption needs, and the Database Encryption SDK extends this to database workloads for DynamoDB, providing field-level encryption that protects attributes. So let's move on to encryption in transit. What should we look at? Well, first, we want to enforce TLS. And we want to enforce TLS and configure our applications to require HTTPS and reject unencrypted connections. We should also implement minimum TLS version requirements. We recommend standardizing on TLS 1.2 or above. And we should monitor for certificate expiration. Expired certificates create both security risks and availability issues. And finally, avoid self-signed certificates. Self-signed certificates don't provide the identity validation that comes with certificates issued by a trusted certificate authority. So I want to show you a couple examples on how you might enforce this. So while S3 supports TLS 1.2 or above, it still does support HTTP for legacy workloads. And you can enforce that all requests occur over TLS via resource control policy like this. So you can see here, we're denying all S3 actions unless TLS is used. But you also need to think about your own applications, and ALB can help you with this. There's a few things it can do for you. One, ALB can terminate TLS connections for you. And you can create certificates in the AWS Certificate Manager and associate it with your ALB. This is really, really valuable. ACM automatically renews certificates before expiration and deploys it to your ALB for you. So there's no downtime and no manual intervention. And then additionally, you can configure an HTTP to HTTPS redirect on ALB, so you don't need to do this on your back end. So let's check in really quick. First, you should turn on Amazon Macie and get visibility into your S3 data. You should enable encryption on all your AWS resources and look at the documentation and determine which KMS key is right for you. And then depending on your data classification, use the client-side encryption SDK to perform client-side encryption. And then lastly, enforce TLS on all of your resources.
Let's talk about secure deployments. We've covered some pretty basic primitives for what you need to get right in the cloud. But the reason you're in the cloud is to deploy software to it. And so let's examine what it means to have a secure software development lifecycle. That your process, that your mechanism of how you release software to run on the cloud is itself a very critical place where you will apply security controls and get security outcomes. That it begins with threat modeling. Before you ever open an IDE, before you even kind of understand the exact architecture that you're going to end up with, you have to be able to reason about the flow of information in and out of the application that you intend to design. This idea is called threat modeling. Understanding where the entry points are for an adversary to do any of the several bad things that they could do to you. Tamper your data, corrupt your data, spoof their identity, and more. And by threat modeling is the responsibility of not only security engineers, but you want your application engineers to kind of be able to think this way too. And as you build tests, and unit tests and functional tests, that the purpose of those tests is not just to ensure that the software works, it's also to ensure that the software is correct, that the software understands what it is supposed to do, and it will resist attempts to get it to do something different. There are lots of very important security outcomes that you're going to be able to achieve by developing really good, competent tests. Integration with CI/CD, even if you're a waterfall shop, the manner in which you integrate new functions and deploy into your production environments is another clear point where security has to be a top priority. By building this way, you can develop agility. And agility is one of the best things about building on the cloud. That if you need an extra computer to try something, you can get it and then turn it back off when you don't need it. If you have a major release and you want to launch a brand new computer with a new piece of software on it and then slowly move traffic over to it, the right way to do that is with comprehensive continuous integration and continuous deployment. But as this software goes out, you want assurance that it is the software you think it is, and that the systems that you're deploying it onto have a sense for what the software they should be receiving. And that's the idea of signatures. You can sign your packages, you can sign your containers, and get good end-to-end assurance about the life cycle and the entire bill of materials of the components that you eventually deploy into your production environments. And while ensuring security in production is extremely important, you should have the same rigor in your lower environments. Because after all, the purpose of the lower environment is to prove out and exercise all of the capabilities, not just of the functional software, but of the release process itself. And then once things are in production, you may need to release patches. Patches to your own software, patches to the components and tooling that you rely on. And all of this fits into a life cycle. And by delivering security and integrating security into that life cycle itself, you can really achieve a lot of critical outcomes. Now, sometimes customers have come to me and said, well, I'm from the governance team, and we've got too many ways of deploying software. So I'm going to pick one, and I want to make sure they can't use the others. And on so many occasions, I've had to patiently explain that while that can be great, disabling these other pipelines is the last step. Because you have to be very careful on this journey that you don't break prod. If you've got rogue teams deploying software today and you want to get them to do it in the new, better, safer way, that has to be attractive. That has to be something desirable. If you go in with the mindset that you're going to turn it off or break it, number one, you become their adversary, which is not great organizationally. It's not great for their quality of life. but also it means that you're really talking about breaking something that the business depends on. And so while there is great value in having a good, known, safe pipeline that everybody uses, if you're going to restrict access to other ways to do it, you do that last. And when we talk about this SDLC and we think about the continuous integration and the safety and the security outcomes that you could fold into it, one of the most important and often overlooked elements is reliable rollback. Yes, it's very cool to be able to automate your releases. But if you're not automating your rollback, that is to say, undoing change, you're only doing half of the job. We know firsthand that one of the worst ways to break a system is by modifying it. And yet, the business demands that we do. And this is the same for effectively every organization. New features, new upgrades, patches, security patches, major releases of software that is going end of life. Yes, automate all of that, but also, always, develop the capabilities to automate the rollback. And just like I mentioned earlier, that the purpose of the brakes of the car is not to slow it down, but to let you go fast, the purpose of the rollback, yes, it's safety, to be able to undo something, but in your confidence of automating it, you can do it more often, and you can do it faster. This is true for everybody at every layer of the organization. The devs will feel more confident about trying new things if they can feel more confident that even if it goes wrong, you can pull it right back. By building this entirety of a secure software development lifecycle with automated deployment and automated rollback, you can accelerate your velocity. And again, what we hear from customers is that one of the best reasons to come to the cloud is to accelerate that velocity. And so the operations of this kind of idea of having a secure software development lifecycle is the operations itself. That I mentioned earlier, that the responsibility of these things is not just with the security department, it's with the people that own this tooling as well. That by automating and refining these systems over time, that you can all work together in partnership, in collaboration, not adversarially, to get high quality outcomes for the business in the form of higher velocity feature release and enhanced safety and security at every step of the way.
All right, let's talk about monitoring and alerting now. And what do we need to consider? First, you need secure logging, and it should span from infrastructure to your applications. And you need to have automated checks that continuously evaluate your security posture, and then alert on anomalies and audit findings, and create automated playbooks to respond to those issues. You also need to have centralized visibility across your entire environment. Security events don't normally respect account boundaries, so implement centralized monitoring that aggregates all those findings from all your environments. Well, let's talk about how we do this. So first and foremost is CloudTrail. CloudTrail should be the first logging you enable, and it should be enabled on every single one of your accounts. It captures all the management event API activity, whether actions are taken via CLI, API, SDKs, or AWS services making calls on your behalf. And for deeper insights, you can opt into data events for specific services like S3. After working with hundreds of customers, I can tell you that having this historical record is invaluable during investigations. So let's talk more about the monitoring infrastructure changes. This is so important for maintaining your security posture. Evaluating resource compliance is an ongoing challenge in cloud environments that are constantly changing. You need to create tooling for continuous assessment of your resources against your security controls and best practices. And managing this at scale becomes increasingly complex as your footprint grows. Lastly, reducing manual errors and interventions is where automation delivers significant value. When systems detect non-compliant resources automatically, You allow your developers freedom to innovate within the defined guardrails. So let me introduce AWS Config. This is our service designed specifically to address those infrastructure monitoring challenges. It records configuration changes as they occur and evaluates them against your rules, giving you real-time visibility into your compliance posture. And to manage compliance at scale, config rules can be deployed across all your environments because they have integration with AWS organizations. So when non-compliant resources are detected, config can trigger automated workflows to correct common issues. Now let's talk more about the logs you need to consider in your cloud environment. We talked about CloudTrail, but we also need to be monitoring and correlating activity against DNS logs, network logs, and audit logs. And there's real challenges with monitoring logs. You need to analyze security signals across multiple data sources because logs in isolation create blind spots. And you need to correlate threats across different log types. An incident often leaves traces across various systems, network traffic and VPC flow logs, or API calls in CloudTrail, and connecting these events is hard. And finding a needle in the haystack of security events is increasingly difficult as your data volumes grow. And GuardDuty helps address these monitoring challenges. It combines machine learning, anomaly detection, and integrated threat intelligence to identify and prioritize potential threats. And it automatically ingests logs from multiple AWS sources, including CloudTrail, VPC flow logs, and DNS queries, so you don't have to. GuardDuty continuously analyzes these events, correlating information across sources to detect suspicious patterns. And when threats are detected, GuardDuty provides actionable findings that include severity ratings and recommended remediation steps. So we've covered everything here so far, except for centralized visibility. So let's talk more about the challenges with cloud environments and how you can overcome them. So we already covered some of these challenges, but when you have a cloud environment with multiple accounts, you have a lack of visibility. It can be really hard looking across environments. And there's so many different tools and data sources, vendors, and your teams get alert fatigue from all of these alerts. And finally, logs and alerts in varying formats are scattered across the organization and tough to find silos. So to address this, and to address the centralized visibility challenge, we created Security Hub. So Security Hub serves as your single pane of glass for all of your AWS security posture. It aggregates findings from our security services, some I mentioned already like GuardDuty, but also Inspector for Vulnerability Management, and Macy. That was for sensitive data discovery. And it does all this in one unified view. And it doesn't just collect all this data, it integrates with AWS Config and automates compliance checks against industry standards and best practices. And this highlights misconfigurations that could lead to security events. And all this, it creates the centralized visibility you need. So here's a practical example of this. Here's a dashboard. This is for our AWS foundational security best practices. And you can see, like I have all of my controls, and you can see which controls are failed, and then you can click into each one of those and get more detail. And this is all in a single pane of glass. So let's check in. What should we be doing? We should enable CloudTrail for all accounts. We should use Security Hub for that single pane of glass and ensure compliance with the Security Hub standards, and that integrates with config. And then we should be using config, and we can create our own config rules for our own customized detections, and then enable GuardDuty for detection. So I'm going to turn it over for Peter to talk to you about vulnerability management, threat detection, and incident response.
So even the best organizations that are really high performing and getting a lot of this right still have to maintain their environments. They have to maintain their environments by managing emergent vulnerabilities. And even if they get that right, the idea of incident response is fundamental. You will have bad days, inevitably. And vulnerability management requires agility. In the exact same way that we talked about speed to deliver new features and capabilities using a great high-performing pipeline and SDLC, those same mechanisms can help you develop agility to patch and update your systems Keep your versions current beyond just patching. At some point, even if you're good at vuln management, you will need to deal with major releases, whether that's a database engine, an application framework, even operating systems. That is necessary for a high quality security outcome, because there will come a day that there will be no more patches for the version that you're on. And you will get squeezed by vendors. Some vendors will charge you even more. We keep certain versions alive here at AWS, but it becomes more costly. We want you to stay on current versions of software, and your developers want you to stay on current versions of software. By and large, new versions are going to be better, more feature-rich, more stable, higher quality outcomes. And so vuln management needs to be a holistic thing, that you're not just responding to a new CVE, common vulnerability, you're also responding to evolution in the software that you rely on. But you need to know what software you're using and where it is. We were all taught a very hard lesson when Log4j happened a few years ago. But we were able to respond because we knew where we had used it. If there's a new vulnerability tomorrow in a particular module, you don't know necessarily where you need to go do the work if you don't have good situational awareness of the software that's operating in your environment. And that means building and maintaining a strong asset inventory of what software your developers are using and where and how it's used. And I say where and how because you need to be able to make reasoned decisions about the speed with which you respond to new vulnerabilities. That the CVE score is just a starting point. That it may be a high score, and it may be internal audit is coming and telling you, you need to patch everything 8.5 and above. But the right way to run a security program is to be able to reason about whether or not the 8s and the 9s are actually dangerous to you. It may be that the nature of the architecture or where it is deployed internally within a closed-off network or publicly anywhere on the internet changes the exploitability and therefore the severity of any given vulnerability, even two that might otherwise have the same score. So make reasoned decisions that include the context of how the software is deployed and where it is deployed. And if you get good at continuous integration and continuous deployment, and you get good at distributed systems, it actually means you can respond to vulnerabilities faster. Because again, anytime you're making change to a system, you are introducing the potential for something to go wrong. By having anti-fragile systems designs in the first place, you can reduce the risk of the necessary activity of changing a bunch of things at once in response to a vulnerability. Now, if you don't have this kind of visibility or you're looking to improve it, we've got some software that can help. Amazon Inspector can give you visibility into not only what's running on your EC2 fleet, but also in your Lambda functions and in your containers, and identify pieces of software that may have serious vulnerabilities. And we are continuously improving this software. And so Inspector began life as just listing CVEs that were installed on a box, but today can introspect your own software in your own Lambda functions and give you a heads up as to whether or not there might be some problems there. It can also help you maintain operational visibility across your entire environment. That this idea of producing and publishing software bills of material become more and more important to perhaps your downstream customers who are going to expect you as part of a compliance program or as part of a regulatory program to be able to produce software bills of materials. And Amazon Inspector can help you do that. I mentioned earlier that continuous integration and continuous deployment is a place to apply a lot of security, and Amazon Inspector fits in there as well. We can help you scan Lambda functions, we can help you scan container images, and everything in between. It's a very powerful tool. There's lots of tools that do this. This one is AWS-ified. We hear from our customers that they really like that about it. But of course, preventing bad days also means expecting them. And that the time to prepare for the rain is while the sun is shining. If you attempt to figure out how to respond when you are being demanded to respond, you will have a bad time. Making decisions under duress or in the middle of the night leads to unhappy engineers who might just leave the second or third time they're paged to a call in the middle of the night and no one knows what to do about it. It also leads to low quality outcomes for your stakeholders, whether that's the board, the shareholders, the PE guys, whatever. That you need to rehearse and plan how to respond to events, great and small, before they happen. And this takes work, and this takes rigor. You can automate tasks around this, but I urge you to be very cautious and mindful about automating decisions. And so automating response to events is great. Automating decisions that require human judgment and management authority should probably not be left up to the computer. If you're just getting started with this, or you're kind of tired of being in the business of it, or you'd like some help, we have a terrific managed service that's not just software, although there is some very clever software that's associated with it, that we've gotten really good at customer incident response. A lot of customers have done a lot of different things and had a lot of different types of bad days, and we've learned a lot from that. And we have a managed offering that can help you do this. There are lots of ways to get help. This is a really good one.
All right, in security, we are never done. We are continuing to look at our controls, our processes, and our systems, and building and improving mechanisms to continue to raise our security bar. But continuous improvement isn't just security. In the AWS, we know that understanding what good looks like across your entire environment is hard. And that's why we created the well-architected framework. And we have a pillar dedicated to security to help you after today understand what good looks like for security and other pillars. We covered a lot of ground today. But if you remember nothing else, focus on these 10 foundational security practices. So let's step through them really quick. First, culture of security. It's non-technical, but it's so foundational, and everyone needs to think about it. We actually had a talk on this yesterday, so if you missed it, there will be a recording that you can go back and watch. Next, enable MFA. It's the simplest, most effective control to protect yourself. And third, eliminate long-term credentials and hard-coded secrets. As Peter emphasized, this is critical. Leverage IAM roles and IAM roles anywhere to provide temporary, automatically rotated credentials, and use secrets managers to manage and store any other remaining secrets. And implement the principle of least privilege. Yes, this is challenging and labor-intensive, but it's absolutely essential. IAM Access Analyzer is your ally here. It helps identify overly permissive policies and unused permissions so you can systematically tighten access controls. Number 5, encrypt data at rest and in transit. This is non-negotiable in today's environment. So take the time to understand encryption features specific to each service you're using and how they align with your requirements. And then implement a multi-account strategy with AWS organizations. This gives you clear separation of environments and workloads. Also, it allows you to implement tailored security policies based off the specific risk profile of each environment. And then enable CloudTrail in all accounts. You should be monitoring all of your logs, but this is a non-negotiable baseline. And then you should be regularly patching and updating your systems. Number 9, implement security scanning, detection, and remediation capabilities. And you can absolutely build a lot of this on your own, but services like Inspector, and GuardDuty, and Macie, and Config are here to help. And finally, centralize your security findings and compliance checks, because it's hard doing this in this multi-account environment. You can also spend time building out your own, but Security Hub is a really valuable resource here.
So again, back to the top. I showed this slide earlier. The good security programs continuously improve, and we've given you an overview. of those areas that demand your attention, your care, your rigorous obsession. That in getting these things right, call them core competencies, are exactly what good looks like. And none more important than a set of norms and expectations for how you think and behave that you could call culture. That the culture of security deserves to be part of your organization, and your organization deserves a culture of security, and so do your stakeholders, so do your customers, so does your auditors, and so does your board. That this culture of security can pervade everything you do. That its security is not an adversary to product engineering. That it's not a team that shows up late and says no. That it is a partner that is there at every step of ideation and development and product market fit. That security was part of it all along. And depending on the organization that you're a part of, depending on the business that you're into, maybe audit and compliance is too. That the truth is you all want the same things. That you want repeatable, high-quality outcomes with a clear explanation of how things work and why you made the decisions that you do. Every engineer wants that. Every auditor wants that. This idea of the security organization making it easier to do the right thing and harder to do the wrong thing. Set expectations. Make clear what is acceptable and what is not. And perhaps most importantly, give those teams the funding and the direction that they need in order to enable truly what good looks like. Thank you so much for being here today.
Thank you.